Alright, more DraftScience video presentation. So, still doing the Quora stuff and just show the argument, show the counter argument. That's all I can do. Just keep pointing out how it's really not on the subject. They just use jargon to get away from the subject, blah, blah, blah. So, continuing. I also dispute your fact because pressure is not measured in joules like energy is. So all these units can be converted. You can convert any form of an energy unit into another form of the energy unit. A joule can be converted to watts. It can be converted into calories. It can be converted into even temperature and pressure. And that's just a fact. It's really just weight. So I'd say it in my thing, but look, a Newton is a quarter pound of butter. Just sitting there. That's a Newton. It's weight. That's a 1 Newton. The weight of a quarter pound of butter. The weight of 107 grams. You drop it 1 meter, and its weight is a joule. How hard it hits the ground is a joule of energy. The whole mass hitting the ground. Now, if you reshape the mass into a little pointy thing, then obviously its pressure will be per square inch. The weight will be per square inch or per square centimeter, per square millimeter. It'll have a weight. The entire weight will be on a different surface area. That's pressure. So it's all the same thing. Anyway, and he's disputing it. That's the same thing. So now we've changed the conversation from why don't 8-pound bowling balls knock down more pins because they're supposed to have twice as much energy, and now we're into this nuance and this nonsense. It's just a subject change. Okay. Fact, because pressure is not measured in joules like energy is. Well, yes it is. It can be. Easily converted. Pressure is force divided by area, Newton meters. So again, it's just newtons, it's just weight. So pressure is just weight. And the idea is how much weight is there per square inch. That's how you measure the pressure, is to put it into a quantity. The total pressure is a real thing, but the pressure has to be applied to a surface. So you're just defining a weight applied to the surface area. While joules are newtons times meters. It's not really times meters. Newtons are just weight. And joules are just weight. Pressure is an expression of force applied per unit area. So again, yes, so what? How does that make it any different? We know that it has a total capacity. The quarter stick of butter has a total capacity to impose pressure. If you impose the pressure on 1 millimeter, there'll be more pressure than if you impose the pressure in some other way. Well, that's not entirely true. Well, yeah, it's sort of entirely true. See, the neat thing about a spring is it doesn't care how you apply the pressure. It doesn't care whether, like you stand on a scale, it measures your entire weight. It doesn't really care whether you sit on the scale or whether, it doesn't really care how you put the weight on the scale. Per square inch doesn't make any difference. You're going to weigh the same. Whether you're standing on a ball bearing, like I could put a screwdriver, I could put anything down. I could put this flashlight on the scale and then stand on the flashlight. It'll still measure my weight. Pressure is an expression of force applied per unit area, not energy transferred. It's always energy transferred, so that's more hoopy-poopy, frankly. Sorry. Having the same pressure is not the same as having identical energies. It's all about whether or not you're going to convert. So yes, it's true. If you're not converting it and you're just measuring it, you're storing it. So the difference between a spring and a lump of clay is the spring stores energy. You push the energy in, you can get the energy back out. A hunk of clay just goes smush, and that's it. You're not going to get anything back. Okay, it converted it all into heat. It moved little sub-pieces of stuff and lost all of its energy to eventually heat. So that's all it did. Converted the energy into heat, and now you can't reconvert it back out, without special tools, without a special instrument to collect heat and turn it back into usable work. But that's the only difference. I mean, one's a storage device. Storage devices are better for measuring because storage devices don't destroy the energy. They don't convert it into heat. That's the whole point. Don't convert it into heat and you can still see it. Convert it into heat and you can't see it anymore. Anyway, having the same pressure is not the same as having identical energy. Instead, the pressure on the spring will be proportional to its mass, to the mass of either object. So again, we're not talking about weighing things. We're talking about things moving. So again, the example is just destroyed. We're not talking about how much something weighs. We're talking about how much something weighs because of its motion, its motional weight. Because the only force acting on the spring are the weight of the objects and the compression of the spring. So the real point is the spring stores energy, therefore you can still see the energy. Because it didn't destroy it, didn't turn into heat. This is how traditional scales work. Duh. I mean, this has nothing to do with the subject, and there's certainly no controversy. I don't need to know how a scale works. And clearly I'm the one arguing let's use springs to measure something's energy. Let's not use clay. Okay, thus the two objects won't exert identical pressures. This is no point. One or more, they will, obviously, they will exert identical pressures in the sense they both have the same momentum and they both have the same weight. So from the spring's perspective, the spring doesn't care about whether I stand on the scale with 1 foot or both feet. The scale doesn't care. One more conservation of energy for spring. So he says again, as if this, telling me what a that gravity is conservational. So this link is something as a gravity link. I mean, completely pointless. Yes, you throw things up in gravity, they come back down with the same momentum. That's exactly my argument. This isn't conservation of energy. This is a conservation of momentum video. Okay, so he's proving nothing. The lab of conservation of energy verified experimentally in part 1, the energy dissipation during the parachute drop. This has momentum is perfectly capable of using the same exact experiment and explaining exactly the result. So it's a spring launches something on a ramp and they test its speed going up into gravity. Yeah, that's momentum. So all he has to do is sit there and tell me the spring produces a different amount of energy. See, the only way you can do these experiments, you have to compare two different objects so you can point out how your spring constant, how your guess about how many joules of energy the spring is creating is wrong. Because they can just make up any number for the spring. If you want mv squared to be correct, all you have to do is change how much energy the spring produced. And you can make anything work. But the point is, if you do two objects next to each other, then you can't cheat. You can't cheat the facts that the spring produces the same energy, and your silly guess at its energy, it was completely wrong. Alright, so useless. It's more evidence from my side than his side. Alright. So he says, it would be more compelling argument if it were true. So he said that about my statement. The comment is perfectly true if read correctly. I never contended that springs compress evenly. Yes, it does get proportionally stiffer. So the spring compresses, if you go halfway, you go 3/4, it doesn't do, it progressively gets, the more you go into the spring, the more energy it pushes out per inch of compression. So per inch of compression, the first inch gives you 50. The second inch gives you 200. The third inch gives you 600, that kind of thing. I pointed out that the spring does not care how fast the energy hits. So unlike clay or other things, it doesn't matter whether I poke it really quick or I poke it slowly. It measures my maximum amount of weight. The amount of energy I'm capable of manifesting to push against it. So it doesn't care whether it's fast or slow. It doesn't care whether the train's going 5 miles an hour or 10 miles an hour. It will measure the weight of the train, the momentum. The spring will accept momentum over a wide range of velocities without biasing its results. So that was my point. And again, he perverts this twice. Anyway. Instead, springs also compress or stretch exponentially in proportion to the spring stiffness. So again, the stiffness isn't the question. The point is that springs are reliable. 100 pounds always produces 100 pounds of compression. Always works. Yes, but it will produce the same energy for the same compression, and it matters not whether you compress it slowly or quickly. So if I want to push a spring in and then lock it, doesn't matter whether I push it fast or I push it slow. Doesn't matter. It's how deep you go in. So just like a magnet, it's pretty good. Okay, it'll give you back what you put in. All right, indicating energy rather than momentum conservation. So again, whenever they say energy, they mean kinetic energy because they don't think momentum is energy. All right. Do you really dispute that momentum is always conserved? Question mark. And if so, will you at least admit that it's a problem for science that there is no consensus among physicists as to this fact? So this really is what's coming into. They keep wanting to change something's momentum, and that's impossible. That breaks all of Newton's laws. Okay, that's the equal and opposite point. You can't say it has a difference in its momentum when the opposite reaction has to be momentum in the opposite direction. The force has to be equal. If the force is equal, the momentum has to be equal. All right. All right, then he says, I also dispute your fact because pressure is not measured in joules like energy is. So I already answered this to you, but I'll answer it some more. A Newton is a weight of a quarter pound. A joule is the weight of that quarter pound after falling 1 meter. See, they define it as the energy to lift a quarter pound 1 meter. But obviously the energy to lift is going to be exactly the same as the energy of dropping. Okay. Pressure is a force divided by area, he says. Doesn't matter the area I spread butter over, its total weight remains the same. Okay, I think good reply, I think. So then he does the N divided by meters, while joules is N times meters. Newton predicted the movement of all the known planets and moons without any of this. So I'm just pointing out that this is nonsense. There are quantities, and they can make relative comparisons, and that's all you need. You just want to know that if this weighs 1 pound, then something else weighs 10 pounds, or something else weighs 1/2 of this thing. All you need is any one thing, any standard to compare everything to. Then who cares? The rest of it's just comparison. Okay. Pressure is an expression of force applied to unit area, not energy transferred. Pressure is just mass of molecules moving. So I'm just pointing out it's just a number of molecules moving, which is the same thing as momentum. A molecule moving is the same thing as a train moving. It carries momentum. It's heat. We call it something else, but it's still momentum. In other words, it's just momentum. Okay. Having the same pressure is not the same as having identical energies. I see no reason to believe it isn't. It's a simple statement. Instead, the pressure on a spring will be proportional to the mass of either object. I would point out that momentum is just weight in a direction. So you could understand that if you're going to measure momentum, it's the same thing as, you're just putting a scale up. So if I was going to measure the momentum of an asteroid, I just go up into space and hold my hand, put a scale up with connected to the Earth. The Earth is this big immovable object, so all I do is take an immovable object, I hold the scale, and I let the meteor hit the scale, and it'll tell me how much energy the meteor has. The scale will read off the pressure. Anyway. All right, I would point out that momentum is just a weight in a direction. So you can sort of understand that all you're doing, we're measuring our weight in gravity on a scale. What gravity is doing to us is imposing a force. So it's giving us momentum. So you're really just measuring your momentum caused by gravity on the scale. It's no different than holding the scale up this way and having you plow into it with some kind of your mass. And how much your mass weighs, that is how much you push, depends on how much velocity you have. So your velocity is telling your mass how much weight you have. Same exact thing that gravity is doing. Gravity is giving you velocity, giving you momentum, causing your mass now to have momentum, the momentum you read on the scale. You do the same thing when you want to know how fast a train's going, how much momentum it has. You just ask it to push a spring, just like you do when you ask to say how much you weigh. Same difference. Same mechanism. Gravity is just a source of energy. It's a source of momentum. Okay. Anyway, because only forces acting on a spring are the weight of objects and the compression of the spring. It seems to me, I say, this seems totally unresponsive to the circumstance I illustrated. The spring is compressed the same amount. Two objects are being launched by the spring compression, one half the mass of the other. One will leave twice the velocity as they travel into gravity, and you will claim it has twice as much kinetic energy when it leaves the spring. So you have the same spring pushing two masses, one half as heavy as the other. Okay, and when they leave the spring, one of them will have twice the velocity as the other. That's the simple point. By their definition, one has twice as much energy. But you know, when they fall, they're going to push the spring exactly the same amount. So what happened to that twice as much energy? Where did it go? Gravity couldn't eat it. Gravity takes, gravity gives back. So where is the extra energy? That's the paradox. They refuse to acknowledge, they refuse to answer. All right, yet they will land and cause the spring to compress equal amounts, revealing no evidence of any extra kinetic energy. So really, this paragraph is the story. I'll just save that for later. Whoops, I didn't get it all. I mean, there's really no point in saying, this is a paradox. They're not accepting the paradox. They're not explaining the paradox. They're not debunking the paradox. It's right there in front of you. Your theory makes no sense. It's silly to say one object has twice as much energy when it's going to land with exactly the same energy. This is how a traditional scale works. It leaves a footnote to a scale, which I already know how springs are compressed. I'm the one advocating for using springs. You're advocating that we measure energy with clay. Okay, so give me some clay references where clay is proven to be reliable in absorbing energy. Okay. Anyway, traditional scales work because springs are very good measures of energy, force, momentum, weight. So I've tied all those four words together, made it very clear. It's all the same shit. All right, thus the two objects won't exert identical pressures, says him. I say, the energy of the spring and the momentum will be conserved. Gravity gives back what it takes. Clearly, that's all you can do. You can't claim gravity stole your energy. It won't steal it. It'll give it back. One more for conservation of energy of springs. Sorry, no compelling evidence provided. The paper you provided could be rewritten as a conservation of momentum paper. All I'd have to do is just change the words to momentum. Every place they say kinetic energy, I just put the word momentum and it works just as good. We likely agree gravity is a conservative force. In isolation, you can pretend one object has extra kinetic energy. So the whole point is if I'm just doing one thing, I'm saying, okay, this flashlight went a certain velocity and it has a certain mass. So I say its joules are 28. I can just make up the force that did it. I can just say, yeah, the force was 28 joules. Did I prove the force was 28 joules? No. I'll just say it. See, if I have two different objects, then you can't do this make up the joules of the spring. The spring's always going to produce 30 joules, 30 joules. You can't make it change. So whatever happens, you're going to have to explain it that the spring produced the same amount of energy. So if you're not comparing two different objects, they can just lie. They can just make up anything. They can say the spring made 1,000,000 joules. They can say it made 500,000 joules. They can just make up any number they want to. Until you do the side-by-side comparison, there's no point because they just lie. They just make up a number. They just fake it and tell you the spring produced the energy. See, it's like the bowling ball example. I can throw a 16-pound ball. We can measure exactly how fast it's going. We can know exactly its momentum. They can do their kinetic energy theory, right, and say, no, it's 510 joules. Right, I'll say it's 200 using Newton's mechanics. They'll say it's 500. They can just say my arm made 500. They won't prove it. They'll just say it. All right. I finished this. Yes, okay, you can just do it. The paradox your formula creates. Energy. You must compare two objects of different mass to reveal the paradox your formula creates. Okay, so I'm just making that clear. That experiments that only have one object in them are too easily cheated. Okay, well, seeing as I've given you the appropriate references, so this is where he starts to get arrogant and obnoxious even. And now you're just misusing definitions. So another claim. If you can't tell the difference between pressure and force, or the distinction doesn't matter, I suggest you high-five a nail and see what you think afterwards. So, I'd like to make some suggestions to him. I mean, just such bullshit, right? So this whole controversy is really about this fact that he somehow thinks it has more energy because I made it pointy. No, you didn't make it. It doesn't have more energy because it's pointy. Okay. I think you're done right here. Yeah. Question mark. So he thinks he's won the argument. He's pretending he produced some sort of evidence that 8-pound bowling balls do have twice as much energy, and they do in fact knock down twice as many pins. And, or does he still believe his first point, which was somehow the 8-pound ball doesn't go as fast, doesn't go twice as fast. Even though it accelerated at twice the speed, it somehow didn't get there. So he's given convoluted mush as a response, and then arrogantly sits there on top of this pile of convoluted nonsense and pretends he won the argument. I mean, you're wrong on all accounts with this one. He said, no evidence of that. At least you were partially right in the previous ones. I don't know what those were. Your comment was incorrect because just like the clay, springs compress, displace exponentially in response to falling masses. So he, again, just lies about what I said. I said springs don't care about how fast the energy hits them. That's what I said. I didn't say anything about the fact that they compress disproportionately. That is, they get stiffer as you go deeper. Yes, I completely agree. They get stiffer as they go deeper. I never contended otherwise. He's pretending I did contend otherwise. This is just straw man shit. Okay. Okay, in response to falling masses rather than linearly. So when they say linearly, they just mean not squared. Okay. The line is this way instead of some preposterous, silly line. Okay, that's why then he just does this u equals 1/2 kx. So again, we're giving me spring constants when I'm not arguing how springs are compressed. There's no argument was made that springs don't compress disproportionately. The argument is that springs always provide the same energy for the same compression. That's the argument. So just keep lying. I said springs are really good storage devices. Are you saying something otherwise? So see, they just change the subject. They pretend I'm making an argument I don't make, so they can pretend to argue something that isn't even part of the argument. I'm not contending any of this. Clearly, this doesn't have anything to do with 8-pound bowling balls having twice the energy, does it? No. Okay. Experimentally, your assertion was incorrect. So, no experiment was provided. This is just such bullshit. To declare victory with a false argument. I mean, this is despicable behavior, frankly. It's just disgusting that somebody would do this in the guise of doing good science. I'm being a good scientist by pretending you made an argument you didn't make and I defeated you. I mean, that's just horseshit behavior. So, again, what seems more true? That he's a religious fanatic evading the facts, or a good scientist protecting the truth? Yeah, I vote for religious fanatic. All right, momentum is always conserved. So this is the joke. He just said in his first comment, momentum isn't conserved. And now he's saying it's always conserved. What can you say? What bullshit? Okay, even you should be aware of that since you cite Newton. That is the charge in momentum. What is the change in momentum? Force. So again, somebody's saying, there's no one arguing here that you have to act on something to change its momentum. A force has to act on it. Yes, if you don't act on it with a force, it's not going to change. So again, another straw man. Complete straw man. None of these experiments are about non-moving objects. All of them are about objects moving and transferring their movement. All right. Whatever a net force is applied, momentum is not conserved. Well, obviously it can't be conserved when you're adding a new force. You can't have the same momentum before the force and then after the force. Duh. I mean, really, big, fat, giant duh. So another straw man argument. When an object compresses or extends a spring, the momentum changes in response to the spring's elastic force. So that's just blah, 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 blah. I mean, duh, 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 duh. This is obvious because though the system moves in the same direction, eventually the spring and the object come to rest rather than maintaining their velocity. So now he's talking about friction again. This has nothing to do with friction. The conversation isn't about whether things on Earth end up slowing down eventually. The subject is if I shoot something into space, okay, with a certain amount of energy, 10 joules of energy, and just because it's light, I make it have more energy. I just make it a lighter object, and it goes faster, therefore it has more energy. Somehow, the 10-pound train going in space, 10 miles an hour, has less energy than the 5-pound train going 10 miles an hour in space. That's your claim. And there's no way to make that claim sensible. Okay, what is conserved? Energy. So again, just bullshit language. So what is conserved? Energy. Oh, you mean kinetic energy? Just in the other paragraph you said kinetic energy doesn't have to be conserved. So now it does have to be conserved? What are you talking about? Oh, that's right. We don't know what you're fucking talking about. I mean, it's just such bullshit. Right, I mean, obviously the dispute is between momentum and kinetic energy. If you're going to use the plain word energy, then there's no conversation, because what does energy mean? Do you mean momentum, or do you mean kinetic energy? The spring takes in the kinetic energy of the mass, so obviously it just takes in the energy, the momentum, right? I mean, just as clearly someone could just say, the spring takes in the momentum of the mass. There's nothing else to take in. Okay, stores it as electric potential energy. That's right, stores it as momentum. Then releases it again in the opposite direction of the initial compression. Yes, and what does it release? It releases a consistent amount. The amount in is the same as the amount out. And it doesn't matter whether I put a light object on that spring or I put a heavy object on that spring, I'm getting the same thing out. The same momentum's coming out. You're claiming otherwise. You're claiming I put a light object on the same spring and I'll have more energy. It's a clear paradox. It clearly doesn't make any sense, and you clearly just keep evading it. This is how springs achieve simple harmonic motion. So again, it's not the argument. There's no disagreement about you put the energy in, the spring shoots it back out again. I mean, it's no argument about that. The argument is you're saying if I put a lighter object on, I have more energy. Because something is lighter and going faster, it has more energy. That's your assertion. And you're showing no experimental evidence demonstrating that there's any more energy. The spring only delivered so much energy, and it doesn't matter whether I put a bullet or a bowling ball in front of the energy. The fact is, I'm going to get the same energy out. The bowling ball is going to have the same energy as the bullet. And yes, the bowling ball won't look very impressive, but the fact is it has the same energy. It has the same amount of capacity to affect molecules and atoms. It can disrupt the same number of them. It can create the same amount of heat. All right, I'm glad you've identified your errors. I mean, isn't that amazing? Not even close to a statement anywhere in here where I identified any error I made. So just, what an obnoxious thing to say. I mean, if I said it to him, oh, I'm glad you admitted you're completely wrong. I mean, you're just saying, again, this is, and he did this in the name of science. Completely mischaracterized this conversation in the name of science in this distorted, perverse way. In the name of science. No, in the name of religion. Regarding the different units of pressure and energy. No, that didn't happen. Okay, but it doesn't do you any favors to conflate terms like that. So avoid it in the future. I mean, what a pile of shit. I didn't conflate anything. I understand, okay, just as Newton understands, that weight is just momentum. Okay, can you hold your beliefs? You can hold your beliefs all you want. Isn't that the great cop-out line? You can be as stupid as you wish. If I said that to him, right, I'd get banned. That's the truth. If I said it to him, I'd get banned. But it doesn't change the experimental truth that spring compression and clay penetration are proportional to V squared, not V. So again, now he's saying springs do, in fact, demonstrate this difference in momentum. So he's saying when I shoot the two objects into space, okay, into gravity, with the same force and disproportionate masses, 2 mass, 1 mass, and the 1 mass goes much higher than the 2 mass, and when they come back down, he's saying the spring shows the light object compresses it 4 times as much. So just like clay, the spring goes in 4 times as much. That's what he's saying. It weighs 4 times as much. I mean, it can't be more of an insane statement. Where did you show any evidence of that happening ever in the history of mankind? Oh, that's right. You didn't show any such evidence. He's just basically saying somewhere he proved that. He showed it. You showed it nowhere. The two experiments are in direct contradiction to each other. That's the fact. The fact is the two experiments, dropping in clay and dropping on springs, show 2 completely different results. And he's just overtly denying that fact and pretending he proved. He showed me the spring moving 4 times as much. No, you didn't show me that. Meaning they are reflections not of momentum conservation, but of energy conservation. So now he says energy is conserved and momentum isn't again. So he just keeps switching back and forth. One post, he's arguing momentum's conserved and energy isn't. You know, kinetic energy. And the next one, he's just saying the exact opposite. Okay, momentum certainly isn't conserved for the clay. Well, you just said the spring and the clay were the same results. You just said it right here. The experimental truth that spring compression and clay penetration are proportional to mv squared. You just said it. Amazing. It's just amazing duplicity. Momentum certainly isn't conserved for the clay. So he's conceding that the clay experiment indicates that momentum isn't conserved. Yet he said it's supposed to be conserved in the previous post. And you see, what's the point of this? This is insane. I'll tell you that much. Okay, and I've already told you the clay experiment is horse shit. It was horse shit 300 years ago. It's still horse shit. Any good scientist would admit that clay might not be very reliable, that it might have a bias for fast things. Good scientists will say that. Okay? So you're just showing you're not a good scientist. You don't give a shit about the truth here. You're just a propagandist for an agenda. And the balls consistently penetrate further than the predictions of momentum. That's the whole argument here. Yes, there are aberrant experiments that will be contrary. Just like the ferrocell shows light being bent by a magnet. Woo, 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 woo. Yes, you can quote mine the evidence to suit your purposes. Is that good science? Is that the question I should ask on Quora? Is it good science to quote mine experiments? Is that now the qualification of good science, is to, basically hide the truth? Okay, for any velocity greater than 1, each experiment I've presented has shown the same result. So there he said it again. No, they didn't. That didn't happen. Even your ballistics experiment, the number was 2.4. Okay, it was only a 0.4% increase in the energy. All right. So then it posted the same fucking... The Newton's second law of motion, like that has something to do with this conversation? No, it has nothing to do with it. I don't remember this one. Let me go to this one. It's a YouTube video. Dum diddy doo da. Okay, good. Mass.
I want to illustrate simple harmonic motion Using a
All right,
mass.
so this is totally useless, okay? I mean, we know the harmonic motion is just redoing a pendulum. So we know that it goes up, it comes back down, it goes up, goes, and it loses energy slowly over time. So this has nothing to do with hanging two different masses on that spring and showing how, hanging them in gravity isn't going to do you much good. But it's not going to show you, it's not going to illustrate the difference between momentum and kinetic energy. Both theories would explain oscillation of a spring. So yeah, way too irrelevant. Alright, so and this one's another mass spring oscillator. Oscillation is not in dispute. I've never said springs don't oscillate. So that's just absolute bullshit. Alright, so this was my last comment. Well, seeing as I've given you the appropriate references, and I say in most cases your reference directly contradict your assertions, or at best fall short of being consistent with your assertions. All right, and now you've just misused definitions. I would say you're misusing the facts of this conversation. My definitions are essentially Newton's definitions. Newton understood it was mass and velocity, which was essentially weight, and that's what controls every event in the universe. All right, if you can't tell the difference between pressure and force, you provide no evidence that weight isn't the most universal description of force. So again, I would argue, if you want a real universal description of what a force is, you understand it as just being weight. You're just taking pieces of mass and moving them, and you're just trying to measure how much that movement weighs, and that'll tell you how much force it has to apply. Okay, or the distinction doesn't matter. That's his claim. Or the distinction doesn't matter. Well, I certainly don't think there's any distinction between force, energy, and momentum. Physics has many dozens ways to describe a unit of energy. Yes, I argue it matters not whether we say calorie, pound, joule, watt, etc. So anyway, I suggest you high-five a nail and see what you think afterwards. So it's really petty, stupid thing to say. This is exactly the point of this controversy. You think shape and velocity define energy. I argue it's just how many matter bits are moving. Energy is in the form of things moving. It can be a big thing, it can be a little thing. That's energy. Things moving, energy. I think we're done here, yeah? I appreciate your willingness to contribute to the conversation, but I don't think you provided any good science. You have essentially just recited religious doctrine, and that's my opinion of the argument so far. I mean, you're wrong on all accounts with this one. You've provided no reasonable explanation for any of the paradoxes I pointed out. So I made it clear. I've drawn them. I illustrated them clearly enough, and he in no way explained why it's not a paradox. Why it's not a paradox to say that a 10-ton train going 5 miles an hour has less energy than a 5-ton train going 10 miles an hour. It can't make any sense to anybody sensible. At least you're partially right in previous ones. So I said I don't recall because I don't recall me previously commenting, frankly. I guess I did. I guess I must have said something on Quora previously. Your comment was incorrect because just like the clay, the springs compress, displace exponentially in response to falling masses. So again, he just keeps arguing about how much the spring compresses. We're not talking about how much. We're talking about the fact that the two objects compress at the same amount. All right, repeating your mischaracterization of my statement is not good on you. I clearly stated springs are fair catchers of energy. Clay is not. Okay, springs are really good. Like I said, I think the value in some of this conversation is you realize something that's kind of a good thing to realize. That things that store energy are really good ways to measure energy because they didn't fuck up the energy. They didn't turn it into heat. And things that convert the energy into heat are really lousy ways to measure it because it's not that easy to see the heat. You know, you have to put the thing in a water tank and absorb all the heat, you know, into the tank to figure out how much heat there is and all that. You know, it's not that simple. Transferring heat isn't that easy because it transfers for every object at different rates. It's not that easy to measure the heat. It's really easy, you know, to see a spring compress. All right. Okay, repeating is a mischaracterization. Yeah, okay, clay is not, right. Rather than linearly. That is why you have blah, blah, blah. While the force, momentum, only kx exponentially, your assertion is incorrect. So I just say absolute gibberish and absolutely no experimental evidence demonstrating me wrong was provided. So again, all of this crap about how much springs compress. I never said anything about springs compressing evenly. I never said that. I said springs don't care how fast the energy hits them. Unlike clay, springs don't have a bias for fast things. Fast things don't get to cheat a spring. Okay, momentum isn't always conserved. Please post that comment on Professor Lewin's video. I can give you links to a few other professors you can correct. Okay, just because it's just too stupid. I mean, obviously that's not what physics says. That's what he says, not what physics says. Even you should be aware that since you cite Newton. So he's arguing that momentum isn't conserved when you're adding a force. Well, of course, when you're adding a force, it's not conserved because you're adding momentum. A force is momentum. When you're adding momentum, you're changing the momentum. Duh. Okay, momentum can be converted into deformation. Where did Newton say otherwise? So obviously, the conservation is a matter of you following the energy. The word conservation, we're just arguing about not so much whether you're transferring the energy 100%. Again, this is the confusion. You can't say you 100% transferred energy, but then you use the energy heat in New York City. This is the argument. You can't use the energy twice. But I mean, I'm just saying, again, it's just important to understand that heat is the energy you can't use twice. You can hit a pin and have that pin hit a pin and that pin hit a pin. So you can keep the energy out of heat for a while. But the fact is, each one of those contacts, you created some heat, so you lost that energy in terms of you didn't conserve it through the transition. You certainly conserved it, and it still exists in the universe. The energy has to be conserved. The momentum has to be conserved in the sense you can't destroy it. But the conservation of its transfer is a different concept. The efficiency of the transfer is one concept. Conservation of the energy is another concept. And science doesn't separate those two very well. So this is just semantics. This is just, you know, playing with a word, conservation, and playing with it very poorly. Okay, what is the change in momentum force 1? Whatever a net force is applied, momentum is not conserved. So he said it again. Obviously, adding a force changes something's momentum. You're just changing the subject. The subject is, can momentum be destroyed, or is it always exchanged? Clearly the argument is you either lose your momentum to giving it to some other object that's going to move, or you lose it to heat. But those are the only two places it can go. There's nowhere else for it to go. Alright, when an object compresses or extends a spring, the momentum changes in response to the spring's elastic force. So it obviously doesn't have an elastic force or whatever that would be called. It's just storing the energy. Yes, with much more reliability than clay. So I just pointed out that yes, that's what springs do, and they do it a lot better than clay. Clay is a lousy spring. It's a lousy storage device because it's essentially converting all the energy into heat. This is obvious because though the system moves in the same direction, eventually the spring and object come to rest rather than maintaining their velocity. So I say, obviously, this has nothing to do with the fact that on Earth, friction will consume energy. That's just a fact. Yes, we're all on Earth. Earth is atmosphere, it's lots of conditions, and those conditions will inevitably mean frictions taking your energy. Okay, the subject is, do 8-pound bowling balls moving twice as fast as 16-pound bowling balls have twice as much energy? So if we forget about the guy throwing it, we just say we know the ball is 8-pound ball, and we know it's moving twice as fast as the 16-pound ball. Do we have any good reason to believe that the 8-pound ball will knock over more pins? And it's obviously we have no good reason to believe that. It's absolutely silly. And yet, here they are defending it. Okay. The subject is, do 8-pound bowling move twice as fast as 16-pound bowling balls have twice as much energy, twice as much ability to move bits of matter. That's what the energy is. The energy is the ability to do work, the ability to knock a pin and hit it and move it. You're saying the 8-pound ball has twice as much capacity to move pins. Do you have any reasoning that can defend that? I mean, why do you think that's reasonable to believe? I mean, it's just so... I'm just saying, you people, okay, I'm amazed you people can actually manage to stay upright in gravity. I mean, how can you believe things that are so silly and you believe them? All right, what is conserved energy? So again, he uses the vague term energy. Doesn't mean anything in this context, where clearly the dispute is what is energy? Is energy momentum, or is energy mv squared? That's the controversy, so this is meaningless mush again. As was earlier pointed out, saying energy without any qualifications is just playing a word game. Okay, so he says, the spring takes in the kinetic energy of the mass, stores it as elastic potential energy, then releases it again in the opposite direction of the initial compression stretching. Like, I don't know how a spring works. Okay. Replace the phrase kinetic energy with the word momentum, and the statement is just as valid. So I'm just pointing out, you're just playing word games. We're arguing over how many joules of energy something has. Okay, clearly I'm arguing that the same force can't produce a different amount of joules. So whatever you call it, okay, the force is 100 joules. Well, that's all it can produce. Your theory says, no, if I put a light thing on that force, I can make more joules. I put a heavy thing on, I can't. I'll lose energy. But you won't explain where I lost it. Okay. This is how springs achieve simple harmonic motion. So again, just more completely off this, way the fuck off the subject. Now you're really changing the subject, I say. I'm glad you've identified your errors regarding different units of pressure and energy. I'm sorry to see you're so dishonest. Okay, so it's just a fact. I mean, what a dishonest statement. I acknowledge no error. But it doesn't do you any favors to conflate terms like that. And then I say, you have no honest reasoning to defend this statement. So there's just no way to honestly reason that I in any way conceded any argument here at all. So avoid it in the future, he tells me. I would suggest you go somewhere. Okay, yeah. Well, anyway, you can hold your breath all you want. Oh, you can hold your beliefs all you want. Thanks for the privilege, but clearly unresponsive mush. Your physics contains clear paradoxes, and you're just running from them. Okay, then he says, but it doesn't change the experimental truth that spring compression and clay penetration are proportional to mv squared, not v. mv should have been. So, and I point out, absolutely no evidence that springs produce the same experimental results as clay. You're just making that up. Okay. Meaning they are reflections, not momentum conservation, but of energy conservation. So it made no sense. I said reflections, question mark. What the hell is he talking about? Momentum certainly isn't conserved for clay. And you say this is supported by good science. So the point is he claims clay is a really good source of measuring, a really good way to measure the momentum of objects is to use clay, because it treats fast things the same as it treats slow things, when clearly there is great suspicion regarding that fact. I'll tell you that much. That's all you've got is telling, no showing. Have you shown the clay doesn't have a biased that allows fast things to penetrate deeper? Question mark. Did you show that? Nope, he didn't show that. And the balls constantly consistently penetrate further than the predictions of momentum for any velocity greater than 1. So again, he's just reasserting the 300-year-old gimmick experiment and saying the gimmick experiment is the one everybody should believe, and let's ignore all the ones that are more reliable and more sensible. So screw doing the experiment in any kind of clinical, responsible, scientific way. Just quote mine the evidence till it agrees with you. Find the evidence that agrees with you. Stop there. You've done. You're finished. That's the good scientific approach. Ignore the controversy. Ignore the fact that the experiments do not say the same thing, and just pretend you're right. That's good science. No, that's good religion. Okay. And springs demonstrate the opposite result. So I point out, each experiment I've provided has shown the same results. That's clearly not true, and the air track experiment shows me to be absolutely correct. Okay. Now, Mickey Farley did throw in some crap here. He also talking about the people I live in the house here. I mean, just more of this trolly behavior, using my real name, all the same old horse shit. People keep defending this stupid creep on the internet, like this is somehow a reasonable behavior, to go follow me wherever I go and harass me with these stupid lies. Amazing. All right, so he just says this part. But when you throw a bowling ball, your body doesn't go backwards, so that video is a straw man. I mean, it's just too stupid, right? Video basically just demonstrates it doesn't matter what you put on one side of the spring, the other side is always 100 joules, 100 joules, 100 joules. Brick wall, feather, doesn't matter. 100 joules, 100 joules, 100 joules. Okay. And this guy actually responds to him saying, indeed, your body would go backwards if you tossed the bowling ball in the vacuum of space. So it's obviously not the vacuum of space that's so important. Okay, it's the fact that you're not on the ground. You're not in gravity. You're not pushed onto the ground. You're not connected to a gigantic mass. So if you're not connected to a gigantic mass, then yes, you're going the other way. Okay. But on Earth, the reaction force pushing you backwards is countered by your body's pushing into the ground for friction and support forces. Well, obviously, you're pushing backwards. You're just pushing the ground backwards. Okay. You don't go backward. The ground does. All right. So I guess we could refresh this and see if there's anything else, but I doubt there is. And it's really a hassle to... You got to keep opening all the threads because they close everything. So this was the John Reynolds post. We might as well read that one. So this is the kook or asshole or douchebag who now has fixed it. But I mean, they changed the name of the question turned into that other weird question. There's just no excuse for that shit. Okay, so he says, don't post stuff like this on Quora. Right? So somehow this isn't a legitimate question. No one should be curious for the answer. I mean, amazing. Seriously, nobody is obligated to go out and bring to your behest evidence that proves to your satisfaction that this or that is true. So obviously the premise of the question is certainly I would like to see the evidence. I haven't found it. So if you can find the evidence, show me the evidence. What's wrong with doing that? What's wrong with saying, yeah, I spent a year looking for it and I can't find it? Go out and find it yourself, see? I mean, it's the same horse shit. What an obnoxious asshole. I mean, it's just such stupid fucking moronic comment. Having said that, your question itself is incoherent. So, I mean, it couldn't be simpler. Science says the 8-pound ball has twice as much energy. How come bowlers can't find it? Okay, and demonstrates you have no concept of basic physics. So this is just all rag. It doesn't make sense to say they were thrown with the same force. I mean, how does it not make sense? The same calories of energy? Should I say that? They were thrown with the same amount of muscular tension? I mean, obviously they're thrown at different velocities, so I can't say they were thrown with the same arm speed, but yes, there was the same amount of energy put in. What other word would you use? That's right, besides energy or force. So it's just so stupid. Without specifying how long the force was applied. Well, obviously it can't be applied too slowly because then the ball can't go twice as fast, could it? I mean, how can I possibly apply the force that's giving something velocity? How can I apply the force slowly and give it velocity? I mean, it's just too stupid. Way too stupid. If both were pushed a distance x with a spring constant k, so again, we're talking about bowling balls for fuck's sake. But even if it's true, even if I used a spring to push the bowling balls, we know we would have to push, the lighter ball is going to go twice as fast off the same spring as the heavy ball. So why is this even contention? The 8-pound ball will be going twice as fast as the 16-pound ball. If I use a spring, that's exactly what's going to happen. Are you disputing that too? Okay. Then the kinetic energy of both balls is equal. So again, it's just too stupid. But the 16-pound ball has more momentum than the smaller. So somehow now the heavy ball has more momentum and the lighter ball has more kinetic energy. It's just too fucking stupid. Alright, we have the equation, spring energy equals kinetic energy. So again, just more horseshit, whatever that is. That's not an equation. That's just a made up silly phrase. That's like poetry or something. That's not a fucking equation. This neglects entropy, which doesn't have anything to do with the subject. In real life, energy in the system is lost in the form of heat, but we ignore that. Yeah, that's the whole point. Ignore that for the sake of this argument. We're really not talking about how much the fact that the 16-pound ball might lose a little bit more energy to friction. We're just saying let's forget about that. You're claiming the 8-pound ball has twice as much energy, okay? Not twice plus 0.4. Okay? No, we're not worried about the 0.4. Anyway, so then he does the typical squish bullshit. Okay, for the 8-pound ball, we have 8 equals switch case, so he's using the spring constant here. So again, nowhere in the example did I say a spring shot the balls, and yet he's using a spring constant, right? So then he tells us what the 16-pound ball is. Okay, so the heavier ball has a velocity 1/2 times that of the lighter ball. I mean, it has it 1/2 times. So the heavier ball has a velocity 1/2. I don't know what that is. It's 1/2 times that of the lighter ball. So he's basically agreeing, right, that the 8-pound ball is going twice as fast, right? I don't know how else you can read that. Thus, the larger ball has 2 divided by 2 equals 2 times the momentum. So he thinks the 16-pound ball has more momentum. I mean, they will both have the same energy upon release. Okay, so just in direct contradiction to the bowling video I played, right, where the bowler reads the book and the physicist tells him the 8-pound ball has twice as much energy, right? So it's in direct contradiction to that physicist. So any physicist who thinks, you throw the 8-pound ball with twice the velocity, because that's just logical. You have the same amount of energy, you're trying to throw it. So if I have a baseball and I make a baseball that's lighter, obviously I can throw the lighter ball faster, right? I mean, duh. Double duh. All right. I mean, really, that one's a little tricky just because I think there's a limit to how fast we can actually move our arm. So it's not going to change much. P.S. The physics Christ, the square root P.S. to the physics Christ. So this guy must be somebody who knows me and just happened to have a year-old account at Quora that he never used. So it does seem like this is just a troll, right? It's like Farley has a bunch of secret accounts all over the place. Anyway, the square root of 2 is greater than 1. So that means the larger ball has more momentum. They will both have the same energy, and so the bigger ball will have more momentum. Now, didn't he just say that it has less momentum? Thus, the larger ball has 2 times the momentum. They both have the same energy. So now he's saying the heavier ball has more momentum. So somehow the lighter ball lost momentum. So in throwing the lighter ball, I somehow didn't achieve twice the velocity. For some wacky reason none of us will know. And that's exactly what the other guy said, right? The 1.4 thing. He basically said somehow I can't throw the ball. And then when he did the acceleration calculation, it was exactly twice as much acceleration. So this is, they don't care about being anywhere close to consistent here. They're just talking absolute gibberish. All right. The square root of 2 is greater than 1, so that means the larger ball has more momentum. Duh. So merely because he says so. Because Leibniz says so, it is so. So because Leibniz doesn't like Newton's atheist physics, that's why it's true. And there really isn't any other reason why anyone should believe it. That's the only reason the stupid formula exists, is because Leibniz thought Newton's physics was too atheist. So just understand the history and understand what you're defending. It's a religious theory, and he's going, durr. Right? He's reciting, the rituals of the Holy Ghost, okay, and then going, durr, like we all have to accept the truth of his Holy Ghost theory. Okay. When you throw a bowling ball, the physics works similarly, but you have to take into account things like arm strength, rotation, torque, but all that's totally irrelevant, and we all know it. I know, you know, that if I give you a 16-pound ball and I give you an 8-pound ball, and you're trying to knock down pins and throw it accurately, that you'll throw both balls with essentially the same force, and you fucking know it. All right, anyway. Also, it doesn't matter what you think the kinetic energy theorem actually says happens. What I just described is a fact. So he just says it's a fact, okay, that the heavier ball has more momentum and that the lighter ball has more kinetic energy. That's the magical truth here. Woo! Yeah. What engineers who look at us to the moon and back believe and rely upon. So that's more horseshit, right? Because we know that the NASA engineers are famous for saying we only use Newton physics. They say it kind of famously. Okay, it is clear from your question that you are confused about the difference between momentum, force, and energy. No, I would argue you're clearly delusional about what those things are. You think they're different things. No, they're just movement of matter. All of them. That's all they are. They don't have any other form than a piece of matter moving. Okay, they are all different things. Only in your deluded psychotic notions of reality. If getting these terms mixed up is something you can't help doing, then your brain probably just isn't cut out for physics. Yeah, this is the part that says, of course this is Farley. Your dad probably never talked to you about this work because he knew you were not mentally acute enough to follow the argument. Well, I know my father knew. I'm pretty damn sure if I asked my father, he would have said, fuck. Yeah. No. An 8-pound ball doesn't have twice the energy. He would have told me that. Okay. You are the missing link. Goodbye. So obviously this is just a Farley account. But it's just a troll account, kind of obviously. And there's 5 people that voted this up, okay? So this complete piece of crap, this steaming piece of shit that proves absolutely nothing, clearly that's totally unresponsive to the question, is there any physical evidence defending the kinetic energy theorem? Question mark. Did it respond to that question with any fucking evidence? Clearly no. And yet what do the Quorites do? They thumb up a fuck answer. A completely evasive, trash, shit answer. Ugh, pathetic. Okay, so I might as well read this other one. And we'll add the replies. Okay, Jesus, this goes on and on. Maybe I'll take a break. Let me see if the other guy ended up responding here, too. The iron guy. So that's here. I responded here, and then the iron guy responded here, and then I responded to him here, Okay, these links clarify nothing, so yeah, that was the last remark. So he hasn't responded to the fact that I point out his links respond to nothing, and I pointed out the 3 paradoxical experiments. Well, I pointed out my original question, which was never answered, and then I pointed out the 2 paradoxical experiments with the trains and shooting things into gravity, and just the fact that I've got no answer to either one of those in any way whatsoever. They have not explained how the paradox isn't exactly what it looks like, a catastrophic paradox, a nonsensical pile of shit. Just as the notion that an 8-pound ball has twice as much energy is absolutely nonsense. Just complete baby talk, bullshit nonsense. No hope that that crap is true. Okay. Anyway, so I'll finish up with another video when I get around to it. Yeah, it's really, the frame rate's going all kind of funny. Anyway, so this has been another DraftScience video presentation. Thank you for watching. Oh, that's the wrong button.